load. That means LOAD. Or no need to calculate the load, just leave it. We have to calculate only P1 and P2 for different angles as well as different power factors. So when I take pi is equal to 0 first. If pi is equal to 0, what is cos pi?
Cos 0, sir.
Cos 0. What
1,
is the
sir.
value of cos 0? 1.
One.
So therefore, this is the power factor. Now the power factor is unity. At a unity power factor, what is the reading of P1? Use these relationships. What is P1? When I substitute pi is equal to 0 here, this should be 0. And this also should be 0. What is the value of P1 and P2?
√3/2
VLIL.
Right,
VLIL.
VLIL into
Root
Cos
3 by
1.
2.
right,
Cos 0.
root 3 by 2, root 3 by 2 into VL IL, right?
Yes, sir.
That means root 3 by 2 VL into IL. What about next wattmeter?
√3/2 VLIL.
When pi is equal
Same, sir.
same, root 3 by
Same.
2 VL into
IL.
IL. So look at both the wattmeters, both the readings are same, right?
Yes, sir.
Right, and also positive. So when the power factor is unity means the nature of the load should be, I can take this as a load. The nature of the load should be resistive load. The nature of the load should be resistive load because both the wattmeters readings are positive as well as both are same. When P1 is equal to P2, automatically the nature of the load is resistive load. The nature of the load is resistive load. Then when I take pi is equal to 60 degrees, here is 60 degrees. Okay. Then what is cos pi? Cos 60. What is cos 60?
1 by 2, sir.
Right, good. 1 by 2. That means 0.5. Right. When I take pi is equal to 60, what is P1 and what is P2 now?
Sir,
What
root
is
3 by
P1 and
2
what is
VLIL.
yes?
Root 3 by 2 into
Root 3 by
VLIL.
2
sir, P1.
VLIL, sir.
Look at this one. When I take pi is equal to 60, what is P1 and what is P2?
Sir, P1 equal to root 3 VL. Root
P1
3 by
is
2
equal
VLIL.
to VL IL into cos of 30 minus 60 minus 30. So cos minus theta is nothing but cos theta. So obviously we can get the same reading, right?
Yes, sir.
Yes, sir.
3
Root 3 by 2 VLIL.
VL IL. Okay, excellent. What
Zero,
about
sir.
P2? 0. Why?
Sir, value 0, sir.
Why?
Cos 90
Sir,
0.
So,
Cos 30
sir,
plus 60
cos
equal
30
to
plus
90,
60
sir.
is cos 90. Therefore, the reading should be 0.
cos 90 0.
So we are having only one load, right? So here we cannot judge whether it is a inductive or capacitive load. We cannot find because the power factor is always in between both resistive and inductive loads. Now, when I take pi is equal to 90 degrees, let us assume this should be 90 degrees. Now, what is a power factor?
So cos 90 0.
0. Right. Then what about P1 and P2 readings? What is
1 by 2
P1? What is
VLIL.
1 by 2 VLIL.
1 by 2
1 by 2
VLIL.
IL. Right. What about other?
Minus 1 by 2 VLIL, sir.
Minus 1 by 2 VLIL.
Minus 1 by 2 VL
IL.
IL. Now what is difference now?
So one positive, one negative.
Negative,
Sir.
Right. The one wattmeter reading shows positive, other wattmeter reading shows same value, but in opposite direction, right? That means negative. Okay. So
Inductive.
therefore, Right. Therefore, this load always to be capacitive load, because from 0 to 60 degrees, if you observe this one, while keeping increasing pi value from 0 to 60 degrees, the power factor is keep on decreasing, right?
Sir.
While increasing
Yes,
phase
sir.
angle from 0 to 60, power factor obviously decreasing from 1 to 0.5. And also the readings of both the wattmeters. Initially, both the wattmeters having same reading, P1 and P2, both are same. But while keep on increasing the power factor value, one wattmeter only showing the reading and other wattmeter reading should become 0. That means one wattmeter reading is positive, other wattmeter reading is to be 0. That means it becomes 0. So for 0, I mean pi is less than 60 degrees. That means second case. If we clearly see this one, when pi less than 60 degrees means from 0 to 60 only. What about these two? Both the wattmeter readings are positive. That means from 0 to 60, both the wattmeter readings are should be positive. So therefore, we are having inductive load that time. Then the total power consumption is P is equal to P1 plus P2. Every time you have to add P1 plus P2. But when I take pi is equal to 60 degrees, one wattmeter reading only we consider and other wattmeter reading obviously 0. It may be P1 or P2. అది మీరు తీసుకున్న దాన్ని బట్టి ఉంటుంది. నేను ఇక్కడ P1 is first wattmeter reading, P2 is second wattmeter reading. If I alter this one, then obviously the first wattmeter reading should be 0, other wattmeter reading should be there. Like that, when 60 degrees of phase angle, that is at 0.5 power factor, what about the both the wattmeter readings means? One wattmeter reading shows positive and other wattmeter reading should be always 0. So, right, at the time of competitive exams, they can ask a question like this. You please ready to answer my question. Right. At what power factor both the wattmeter reading should be equal?
0, sir.
Power factor 1.
1,
Right,
sir.
power factor is 1. At the unity power factor only, both the wattmeter reading should be same. Right, one more question I am going to ask. At 0.5 power factor, what about both the wattmeter readings?
So one is positive, another is 0, sir.
Right, one wattmeter reading only it is showing, other wattmeter reading should always 0. At 0.5 power factor only. For less than 0.5 power factor, one wattmeter reading is there and other wattmeter reading is slightly decreasing. Okay, right. I hope you understand the concept. Now for pi is greater than 60 degrees. That means I am taking pi value is greater than 60 degrees. So I'll keep on increasing pi value from 60 to 90. What about the power factor again?
Decreases.
Decreases. So the power factor is decreasing. At the same time, one wattmeter reading is to be slightly decreasing, and automatically the other wattmeter reading is going to be negative. అంటే అది 0 కూడా క్రాస్ చేసుకొని నెగటివ్ లోకి వెళ్ళిపోతుంది. While keep on increasing the power factor, while keep on increasing the angle, అంటే యూనిటీ పవర్ ఫ్యాక్టర్ నుంచి 0 పవర్ ఫ్యాక్టర్ కి నువ్వు ఆ పవర్ ఫ్యాక్టర్ వాల్యూ కనుక తగ్గించుకుంటా కనుక వస్తూ ఉంటే, initially at 0 power factor, unity power factor, both the wattmeter readings should be positive. While keep on decreasing the power factor from 1 to 0.5, from 0.5 to 0, so both the readings will be decreased, but one wattmeter always shows a positive value, but the other wattmeter reading always become 0, again become minus value. So this is the concept. So therefore, for pi greater than 60 degrees, there we have that is power factor is less than 0.5, the P2 is negative. In such a case, the connection of either of the current coil or the potential coil are to be reversed to make the positive deflection. So the value of P2 should be then taken as a negative while calculating the power factor of total power. So that this analysis we have to remember while doing the problem. When you get the one wattmeter reading is negative means that time what we have to do, that I can explain at the time of problems. But you have to remember this table. So they can ask a questions at any cost. I mean, any type of questions they can ask from the table. Say at what power factor wattmeter readings, that is one wattmeter shows positive, other wattmeter shows negative, means at 0 power factor only one wattmeter shows positive, other wattmeter shows negative. Okay.
Sir, what is the nature of load, sir? At 90 degrees.
Right. Generally, nature of the load is always connection of the, actually, if both the wattmeter readings are same, then we can have resistive load, obviously.
Resistive, sir.
Right, resistive. But while coming to remaining parameters, that is for an inductive load or for capacitive load, we cannot judge directly over here. That is always depends upon the readings of the wattmeters, P1 and P2. So if P1 or P2, whatever it is, if P1 is greater than P2, that means if one wattmeter reading more compared to other wattmeter reading, we can say this is a inductive load. If P1 is less than P2, then we have capacitive load. That means we are assuming P1, P2 like this only. If you take first one is P2, second one is P1, then the reversion connection, I mean, this concept will be reversed. That is P2 is greater than P1. That is nothing but inductive load. When P2 is less than P1, that should be capacitive load like that. So the load, whichever, that is what type of load is connected, means that depends upon the impedance which is connected in the circuit. So while doing the problem, there you can understand how to calculate. అంటే మీనింగ్ ఏంట్రా అంటే ఇక్కడ నేను P1, P2 అనేది మనం అజ్యూమ్ చేసుకున్న వాల్యూస్ ఇవి. ఫస్ట్ వాట్మీటర్ రీడింగ్ ఇదని, సెకండ్ వాట్మీటర్ రీడింగ్ నేను ఇలా ప్రొసీడ్ అయ్యాను. లేదా నువ్వేమనుకోవచ్చు డయాగ్రామ్ లో, ఇఫ్ యూ గో టు ద డయాగ్రామ్, రైట్, why should I take this is Z1 and W1 and W2? I will take this is P2. I will take this is P1. That is your choice. That time the conversation will be different. So the nature of the load is always depends upon the type of the impedance. That means if it is impedance having R plus J into XL, then we can call it is RL load, or that is inductive load. If it is a combination of resistor and capacitor, we can say it is a capacitive load. Okay, but the total load is always depends upon your connections, that is P1 and P2. That is your assumption. If P1 is more than P2, then it is an inductive load. If P1 is less than P2, that is for capacitive load.
Capacitive load.
P1 is equal to P2, then we can call it is
Resistive load.
resistive load. Okay, that, I mean, as per our discussion only, that is possible. But if we connect, this is P2 and P1, these connections will be, I mean, this controversy will be different. Automatically P1, P2 can be changed. Okay, so that you can understand at the time of problems. So this is what about how to measure the power factor using 2 wattmeter method, that in a balanced 3-phase circuits. This is very, very important table. Everyone should form this table. Okay, I can explain total problems. There are 3 problems are there. I mean 2 problems. The 2 problems I can explain tomorrow. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.